Hello and welcome back to the Building HVAC Science Podcast. It's our goal to create better, more knowledgeable HVAC and building performance technicians by helping the two professions to better understand each other with the ultimate goal of making customers happy in the homes they live in and the buildings they work in. Technology. It's always moving ahead, always advancing. I had the great opportunity to speak with my friend Ben Walker, who's Co-CEO of Retrotec, about a wide range of technology-related topics from sensors to programming to AI, artificial intelligence. Ben's going to share with us in this episode his experiences over his career in tech companies, primarily with Retrotec. And Retrotec is one of TruTech's major vendors of air tightness and airflow testing gear. We learn about the history of digital manometers at Retrotec, as well as the important topic of enclosure integrity testing, something you may not know about, but it's really important to our world, and how to manage large building testing. Large buildings need testing too. Other topics we touch upon include the move to DC motors, rCloud, which is an app-based test data platform, and really so much more. And the long list of new features in the DM32X digital manometer, one of which is rCloud. Got some links in the show notes to Retrotec products and specifically the DM32X digital gauge. It's really a beautiful piece to put in your hand, sort of like an iPhone, but not really a phone. Although Ben says some things about that in the podcast you can hear. Also got links to Ben's LinkedIn and a link to openai.com, which is where Ben suggests you give ChatGPT a try yourself. So let's get into the conversation with Ben Walker from Retrotec. It's been a while. Been offline for a couple weeks now, or feels like a couple weeks. Been doing some travel, and one of the people I met on my travels, or meet frequently, but got to meet in person again, is Ben Walker here. Hello, Ben.
Hello. Yeah, thank you.
Ben, tell the listeners who you are, what you do now, and give us your history, because you've been with a company called Retrotec for 27.
It gets a little bit complicated because there was like an in-between, but
long time.
A long time, actually. All told, a long time in the building science world, building test instrument stuff. But yeah, my name is Ben Walker, Co-CEO of Retrotec. Myself, Darren Kennedy, and myself have been co-CEO for about 5 years now after the founder, Colin Genge, retired. He's the guy that initially hired me back in 1995. I answered a classified ad in the Bellingham Herald for a computer networking position. And look at me now. I owe a debt of gratitude to Colin for just all the opportunities he gave me and everything, letting him let me do my thing technically for Retrotec for all these years and everything, building manometers, working with the blower doors and the Cal Lab and the software teams and everything like that. So that's one of my favorite things to do, is just bring new technology and things like that into this industry specifically.
So give us a quick update on Retrotec, the whole business. Like, when did it start? A little bit of that evolution, and then you could talk about your phase in there starting 1995.
I think that my best recollection is that Retrotec started with Brendan Reed and a couple other people, including Colin, back in the early 80s. And I think the business started in Ottawa, Canada. I think that's where the birth of the blower door occurred, was in that region. So yeah, I think then Brendan Reed had hired Colin to calibrate the first blower door that they'd manufactured or something like that. So that's how they met. And they worked together for quite a number of years. And Brendan Reed eventually moved off into doing Comfort Institute, and Colin the whole time started the manufacturing of Retrotec in Bellingham, Washington. That's where I met him in 1995. I think he started there in the early 90s. Yeah, then he was mostly in the beginning focused on some enclosure integrity stuff. He wrote the Appendix D standard for NFPA.
So explain what that enclosure integrity is.
Instead of discharging these volatile gases into clean rooms to test the air tightness or the retention time of these agents as they're put into like a computer server room or whatnot, then they do simulated discharges using a blower door just to test for leakages, then calculate based on the agent and how much of it is in the tanks and everything, just what that retention time would be, making sure that it's got that 6-minute retention hold time for protecting servers or whatever asset that you're trying to protect.
So it's about fire safety?
Yeah, it's fire safety, yeah. Like, I used to work in data centers that would have tanks of FM200 in them. Because I had my history with Retrotec before then, I was like, oh, I know exactly what this is all about. And they had like an emergency button to press if you were in there when the FM200 went off, because you can't breathe when it goes inside there. But yeah. So you just hold your breath, push the button, and run out.
It's meant to protect the equipment, not people.
Yeah, it's meant to protect the machines, exactly. It will suck all the oxygen out of the room to extinguish the fire. without having a sprinkler system or anything.
And you want that to stay contained for enough period of time so the fire goes out. And that's why you got to make sure the enclosure has good integrity, that gas stays in there. Okay.
Exactly. Yeah.
Interesting.
So he kind of wrote the guidelines and the testing standards for that particular industry and market using the blower door.
When you came on board 95 and you answered that classified ad, you have that classified ad like stuck on your bulletin board or something?
I should.
You got to find that.
I do remember I was only 22 at the time. And I remember the interview over the phone with Colin actually pretty vividly still really or whatever. And then I said, well, what kind of experience do you have? And I said, well, I have 3 computers. They're networked together here at my house and I use them all day long. And he said that was the line that had him intrigued enough to bring me in for the in-person interview and everything like that was like that line there.
And the rest is history.
And the rest is history. Yeah, exactly. So then I started working back then. And I had the infiltrometer. It was the trademarked blower door name back then. And we were working on the infiltrometers and they had the big magnehelic wire gauges back then, the analog ones. So there was 3 of those, 2 for measuring flows from the fans and 1 for measuring the induced pressure inside the enclosure. And like these HP200LX palm tops, which ran like the manual J calculations and this enclosure integrity stuff. That's what I worked with Brendan on doing a lot of that programming and stuff. And then also work on the CRM, doing marketing campaigns and just helping people out with software support and just working with the internal team there.
So was it the majority was in the enclosure testing? And when did it start to move into building science?
I think it was about a 50-50 mix even back then, actually, really. Now with Colin, like I mentioned, is more focused on that. And then Brendan Reed on the other side of the business, a little bit more focused on the home performance. And it was always about indoor air quality and comfort was the big thing for them back then for why to do a blower door test along with the energy savings and everything.
So you made this jump from 3 magnahelix to a digital pressure gauge. That was your project?
Yeah. It's funny because I've always been doing programming and computer stuff since I was like 12. So always interested in technology. And then I approached Colin and I asked him, I said, hey, can I work on a digital manometer for you? And he said, no. He said, we had other priorities in the company and everything. And he told me no.
Absolutely not.
Absolutely not. So I did the thing that I typically do in those situations. And I just went ahead and did it anyway, but on my own time. So I worked on this DM1 with a friend of mine, Brian Kelly, who was a really great electrical engineer, on this gauge just in the evenings. And then after it was about a year before we had like this really fully fledged out working prototype where I felt comfortable going back to Colin and saying, hey, check this out.
What was his reaction?
I think it's taken aback a little bit in the beginning and then like curious about what was that crossover between how much was I working on it at work versus home and all the rest of the stuff, whatever. But at the end of the day, it all worked out. I was excited about it. I still see a couple trickling around once in a while, which is neat to see. And
what do they look like?
There was in a stock enclosure, so they just look just like a brick. Back then, there were like is an analog pressure sensor that you'd have to tie into like an instrument amp to amplify the signal, and then you're like rolling your own AD converter, and you had to pull all those things together, and it was a lot of work. And like we're programming in 8 bits at a time. Really, it was crazy back then. It's so much different now. It's so much easier now. It's just neat to see the evolution too between then and now, and still be a part of it.
At that time, it was used for both blower door testing and duct leakage, or the duct leakage. When did that come in?
I wish I could show pictures and stuff, but we did have these antiques kicking around where it's just like this big Corex box with a motor in it, an impeller motor that they would use for doing duct testing, which the 3 magnehelics were like glued into the face of it and everything with just tubes and wires going all over the place inside of it and stuff. It's pretty remarkable. Yeah.
Very much like a garage built kind of thing.
Exactly.
TruTech came on board with Retrotec in the era of the DM2, 2A.
Yeah, which I guess that'd be like the early 2000s or something like that.
It was 2A, so there's another one in there. So what's the difference? Like the 2 actually started to look more integrated?
Actually, the DM2 I worked at Retrotec from 1995 to 2000. And I was away for probably 7 or 8 years like this. It was during the .com era. And then this couple of my friends' dads started a .com company. And it seemed like, oh, that'll be really fun to work with my friends and stuff. So that was really the only reason why I left Retrotec. And then I came back and it was probably 13 years ago. So like 2009. So I missed out on the invention of the DM2, and then the difference between the DM2 and the Mark II, I think, was just some firmware functionality and a little bit more automated PID control for the fans and things like that.
Was the DM1 doing calculations?
I would only really do display pressure in pascals and inches of water. We only had those 2 modes.
So it's simply a digital pressure meter.
Yeah, exactly. With it's had a 9-volt battery in there. Used to calibrate them with one of those micrometers, like a hook gauge, like a very involved. Have you ever seen one of those hook gauges before, where
Yeah, I think I have.
like the hook, you dial it in until like the hook barely is about to break the surface of the water, and then that was your measurement and stuff. Took a long time. And that's how we'd calibrate DM1s back then.
So then I moved on to the DM2 and just the breakdown of the business. You came back for the DM2A or the Mark II? What was?
I think those products had been out for probably maybe 6-7 years or so before I came back, I think. And then Colin saw on LinkedIn that I'd taken the summer off and I'd been doing some contract work and stuff like that. And then he just called me and said that, what do you think about coming back? And I was like, oh, I never even thought about it for whatever reason. So I said, yeah, sure, let's do it. Sounds great. And then initially just doing some software dev stuff. And then there was another gentleman at Retrotec that was part of the product development team there. And then during Christmas break, like when I'd only been back for a few months or something like that, then he never came back from Christmas break. And then we found out he was going to go and start his own blower door company. And he had started this product development stuff with another gentleman. And him calling us to ask if we could pay these unpaid bills was how we started the evolution of the DM32.
Okay.
That's a lot to unwrap, but yeah.
A little corporate espionage there or something going on.
Exactly. So it all got worked out, but that's how I met the same individual that I worked with on the hardware development for the DM32, and then also this new, I'm sure we'll get into the DM32X. Same individual, yeah, so it's interesting.
So the package size in the DM32, if people aren't familiar with that, that's pretty compact. It's like 50% larger than a deck of cards, something like that.
We always, like when we started working on the DM32X, like the first thing I approached the industrial designers with is like, I want to make this thing as thin as possible. That was my first sentiment to them. And it's in the notes, you can still see it or whatever. But yeah, just trying to condense everything as much as we can, make it compact and portable and versatile. Yeah.
But the DM32 itself, that one was launched like in the early 20.
It's probably released then, but I actually started on it probably just shortly after I got back. So like say 2010 or something like that. It probably took me a year and a half, 2 years to complete the development of it and stuff before it got released. So
what were some of the key upgrades? What did you take from the DM2 Mark II to the DM32? What were some of the things you added to it and why, really?
Yeah, I guess the DM2 could do this basic functionality stuff and was a limited LCD display. And the DM32 was like our first opportunity to like integrate Wi-Fi, a full color touchscreen. That was new. That was like a new thing for the industry even at that time.
Yeah. And even like illustrations of the fans that the meter would connect to.
Yeah, we're trying to make it easy for people to identify which range of the fan they were on and things like that. Trying to use like illustrative or photorealistic, which we have now, images of all the ranges on the fans.
Right. Eliminate a little point of confusion, speed up the work, give more confidence.
Exactly, yeah.
How does the Wi-Fi get used for the listeners?
So, some situations where maybe somebody's doing some air sealing in an attic or something like that, then he will remote control his DM32. Like he'll have the blower door and everything set up in the front doorway. And then be able to remotely turn the fan on, depressurize the building or pressurize, and then just be able to monitor his sealing work along the way.
So you could actually like grade yourself. Are you making progress towards a goal?
Yeah, exactly. You can use it for that. And just having that remote control ability, like from your phone, just over Wi-Fi, you can remotely control this blower door.
Remote control and values. I mean, you'll see.
And see the measurements. Yeah, on your phone, you see exactly what's going on the display of the gauge itself as well. And then also it gets used for doing like large building testing, multi-fans, where I might have 12, 24 fans all connected to the same laptop.
Tell me about multi-fan testing, because that's something that maybe some of our listeners aren't familiar with. Why do you use it? And what things do you do to make it easy? What things does Retrotec do to make it easy?
It's about ensuring that you can get these fans distributed all over the building. So another option of the DM32 was to be able to connect multiple gauges just over wired Ethernet, which is probably the most reliable way to do a large building test, because you really do have fans all over this large building. And
maybe something people, again, don't know, but Retrotec, it does have global sales, because I've seen some pictures from some really large buildings where you've done fan testing. Tell us a little bit about those big projects.
At times people have, like I mentioned, like 24 fans all connected, and then they might just be trying to isolate and measure the leakage of one floor at a time. And so they'll have their target area that they pressurize between 12.5 to 75 pascals doing a multi-point test. And then they have these other fans rolling along on the other floors, maintaining that same pressure. So it like neutralizes the boundaries between the floors. And then now you're only measuring the leakage to outdoors from the target area that you're trying to measure. They can do sampling through the building, or typically they would maybe start at the bottom floor, also do the top floor, and then do some sampling in between on the other levels and stuff. Because it is part of energy code around the world these days, is to ensure the energy efficiency of some of these new buildings that we're building, and do a lot of testing in Seattle and stuff, and it's all over.
First, when I first encountered it, the large building testing, I'm like, this is magic. How can you control? Isn't one of the issues like a fan can start to like reverse flow the other one, or there's interactions that can happen?
There's a lot of technical challenges, that come with so many fans in one doorway. There will be challenges, just like you mentioned. You got a 3-fan panel, and the middle fan is being influenced by the other 2 fans, and then starts to go in reverse. And then luckily, we have a lot of catches in the software now and stuff like that will like red flag and identify those issues as they come up in the middle of the test and everything. But that's why there's a big push for a lot of people moving to DC motors for the blowers, because then it's impossible for it to go in reverse then.
Interesting.
Which we have some cool new things still on the horizon later this summer. So around that.
So nobody's got a DC motor out there yet?
I'm not going to mention them.
Somebody has a DC motor.
In Europe, yeah.
That's cool. It's your company. Give us a quick overview, the process of doing a pressure test, either on a duct or an enclosure or a building. We talked a lot about the pressure gauge, but what about the equipment that actually generates? How do you measure the pressure? How do you measure the flow? Just give us, our listeners, an idea of that.
Maybe let's start with the house, because everyone can relate to like a house and living space. And the purpose of the blower door test, like I mentioned, there's maybe 3 things why you would want to do it. One would be like for trying to identify leaks around your building and your doorways and windows and any other penetrations that come through where you're maybe, like you like to mention, like you're losing your expensive air that you paid for. You want to keep it in the building, really. And then for air quality issues, maybe your house is under negative pressure all the time and you're pulling in air from the contaminated pathways like your crawl space or your attic or something like that. So you just want to make sure that all those areas are well sealed from your main living space. And so you would take a large fan, the blower door, and then we have a cloth canvas that you put in that seals off the doorway, the front door, and you'll install the fan into the canvas. So then it creates that air barrier between the indoor and outdoor with the fan in between. And then you'll use this digital manometer to plug it in so that you're taking a reference between outside and indoor pressure. And then you're also taking a pressure difference between the nacelle of the fan and the outdoors so that you can get a sense you convert the pressure in pascals across that fan into a flow like CFM or cubic meters per hour. And then that will give you a sense for like how much air is leaking out of the building, what the hole looks like in the envelope.
The aggregate hole from the whole envelope leakage.
And then the gauge the standard calls for depressurizing or pressurizing a typical building at 50 pascals, which is kind of like simulating a certain amount of wind load on the building. And then with that wind load, then that's what the infiltration that you might experience or something like that in the building. So that's why you pressurize or depressurize the house to 50 pascals and then take the measurement of how much flow, cubic feet per minute of air is going through the fan at that time. And that gives you a sense of what the envelope's acting like.
And beyond the blower door and the duct leakage has a similar thing. You have a different size fan. You hook it up to the enclosure as the duct work, and you measure the leakage flow. You seal off everything, all the normal flow paths, and you're looking for the bad flow paths, the things that shouldn't be there, the leakage. Yeah. Okay.
Yeah, there was not that long ago, I was crawling around in my own crawl space and I realized that there's a big slit cut in the return air duct underneath my house for the return coming from downstairs or whatever. So I was like, after, it's like the landscaper whose yard's never mowed or whatever. I'm like, maybe doing this on my own.
Because you're always out busy doing someone else's work.
I got that fixed.
You can do more with pressure gauges, right? There's other tests, like even around the home.
Sure, yeah. People will use them for doing like zonal pressure diagnostics to see the effects of running their air handler and see if it's maybe depressurizing a bedroom, like I mentioned, and then maybe pulling in air through the crawl space or whatnot, things like that.
And also things like pressure pans. How do they get employed?
Yeah, they can also use a pressure pan where you can connect that to the gauge and then you're checking to see the connectiveness between the attic and the inside of the space and things like that.
You make something called the flow box too?
Yeah, exactly, which you can also use for measuring exhaust flows through bathroom exhausts that you might be trying to commission or whatnot. Or it's surprising, actually, how many applications that people come up with using these gauges for and things like that. But
pressure testing is really pretty much magic because you can't see the air moving. But there must be so much, is there theory behind this that allows you to make these projections of leakage rate? There must be some underlying theory, probably coming from the work Brendan and Colin and others have done over the years.
Exactly. It's coming from the history of all the physics and everything that have come into play. There's definitely physics involved. You say magic, but there's no magic really.
Yeah, no, to the uninformed.
And then it's like a Bernoulli effect through the fan, like it creates a pressure drop. That's how we measure the flow rates through the fans and things like that. And the pressure inside of your building just following dynamics of fluid dynamics.
So you mean you just can't go down to Home Depot or Lowe's and buy a big fan and use it?
No, you shouldn't really. It should be we do calibrate them too, and we have an accredited lab, ISO 17025.
You don't calibrate Home Depot fans.
No, we don't calibrate Home Depot fans like our own. That's what I'm saying. But just the importance of, making sure that the instruments you're using are actually precise and calibrated. It is important.
And you mentioned the flow over the nacelle of the fan. That's got to be a precision arrangement there in order to make a measurement?
Exactly. Just as you produce a few prototypes of the fan, then you have the placement of where that flow signal is in the nacelle. And you just want to make sure during manufacture process that like you have concise placements of all those components and stuff. So specific measurements and stuff that we take to make sure that those nacelles are always in the same spot. And then we go through and then we do calibrate each fan individually too on every single range. When you purchase a fan from us, then you'll get a certificate that shows all the points and the measurements and the error and expanded uncertainties and all that stuff in the fan.
The fan's actually a measurement device. That's the thing people have to keep in mind. You showed me something at the symposium that was coming from overseas.
Sure. That was the air tightness tester for Mason. That could be that.
You want to talk about that?
Oh, sure. That's fine. Yeah. It's a newly developed product for Mason that they use for some air tightness testing in the Netherlands specifically. And they still use it with a blower door in conjunction. They go and actually get preliminary numbers for if there was a quadplex or a 5-unit building or something like that. They'll still use a blower door test, get some sampling and stuff like that. But then they have this air tightness tester, which is just a plastic pod with like an absolute pressure sensor in there and stuff. So then they just use the exhaust of the air handlers. Like they can put their air handlers there in like exhaust only mode, I think. And then either that or using the bathroom exhaust fans. They can take a measurement of the flow through those and then use that ATT tester to determine the pressure difference inside the building, the very low pascals, and then determine the leakage rate. Yeah. It's kind of a new thing, and actually still I have 2 or 3 of them now, and I've just been testing them and comparing the results and stuff like that, and hope to work closely with Nick Young at ASIN and everything like that. So we have a great working relationship together, and just making sure that it's a product that really works for people in the States as well.
Sure. So you and I saw each other, was it just a week ago?
Yeah, it was just a week ago, yeah.
Oh my gosh. At the National Home Performance Conference. It's sponsored by the Building Performance Association. It was a big event. I got the numbers, 2,700 people were at the event.
Yeah, it's amazing. It's post-COVID. Everyone's back. It feels great, really. It's great to see people again. There's a lot of great people in this industry, and we have been cooped up for years now. So it's fun to get back out there and meet people and stuff.
So you had a nice booth there, an exhibit. Your colleagues were there. What was the vibe you picked up from the event? It was like a 4-day event.
A tremendous amount of excitement. Just everyone excited to be back at it. And then from a Retrotec's perspective, whatever, it was amazing because this was like our first opportunity to really promote the new DM32X.
Yeah.
And then just went into production starting on March 1st. And up until that time, it was a race for me. I was working 12-hour days for 12 weeks, 6 days a week. From Christmas break until March, and I kept postponing things like meeting with you and things like that for that reason. It's just so focused. Because I will mention, one of the things COVID was just supply chain issues and stuff. And what we found with the DM32 and stuff is that technology had been like 10 plus years old and became impossible to source all those components anymore. And we knew we were going to run out of a component that we could not get anymore. And so we had to complete this project. And so a lot of pressure on the entire team. And it was amazing actually to see all the people at Retrotec really pull together these last few months, and like the software teams making sure that the new gauge works with fantastic, and the marketing and sales teams, everybody just pulling together to rally around making sure this was a success. And that's why it was so exciting to be at that show and actually having gauges to bring there and to sell, and is great.
Talk about some of the new features in the 32X.
Yeah, it's really a revolutionary platform because in this building science world, because it's like a mobile phone with pressure sensors. That's what I really think about it. It has all the horsepower of your modern cell phone, just without the SIM card. It has the Bluetooth technology, Wi-Fi, has this beautiful 5.5-inch capacitive touchscreen that's made out of Gorilla Glass 4 for ruggedization. compact. And it's just to be on the Android platform to develop future applications and updates for people is almost seamless for us now with over-the-air updates and stuff. So it used to be like a little bit of a chore to update before, but now it's super easy.
But it's not a phone. You didn't take a phone and repurpose it.
No.
I just want to make that clear. Yeah.
Now it's like a ground up design that.
It's a product that's by unto itself.
Yeah, exactly. But if it had a SIM card, you could make a phone call with it. And you can run any app on it that we have our own store that we publish apps on. And then we're working with a bunch of partners like Hike Micro because they have their Hike Micro C products that with the USB-C connection that you just plug into Android. And now you can do thermal imaging on the same DM32X gauge. And same with like inspection cameras and things like that. Just a lot of versatility.
Cool. You also mentioned Fantastic. We skipped over that. That's your software.
Yeah, that's our Windows software that people will use around the world to generate reports on energy audits and air tightness testing that they did with just from passive house all the way up to these large buildings that we mentioned with 24 fans.
You can actually control the fans through the software?
Yeah, exactly. Yeah. Each fan is connected to one of these gauges, and then the software interfaces with the gauge to get the pressure readings from that fan and then uses that for the total calculation of the leakage rates and stuff.
Got it.
And we revamped from January till now. The software has progressed a lot with this DM32X for little issues that would happen in the past, whatever, have been resolved with the new gauge and stuff, which is great to see.
Knocking them out. Good deal.
And the most important thing, like Joe Madoff would kill me if I didn't mention this, but he helped me work on this. But our software, rCloud, which we had for Android and iOS, is now like native on the gauge now. So you don't need to like connect to another phone or anything like that to run our rCloud software, which walks you through the process of taking a bias pressure baseline and all the steps in doing an air tightness test on a building, and then saves the results in the cloud. It will work offline as well, and then you get a really nice report that you can show the homeowner or whoever is responsible.
Nice.
Yeah.
Back at the symposium, we started to talk about artificial intelligence and ChatGPT. We've had some more conversations on that. Share some of your thoughts on that area, because I think that's an intriguing one and will tickle the minds of a lot of the listeners.
There's a lot of mixed reviews about it because the initial releases of, say, ChatGPT and stuff like that were like early models, and people would see some of these hallucinations, they call it, when you're asking questions and things like that. But over Thanksgiving break, I'm not sure what happened with me, but I really got in this big mode of learning Python. And so I was like learning how to program in Python at the same time as like ChatGPT and OpenAI and all that stuff released at the same time. And so I started using ChatGPT to help me write code. That's like the most phenomenal thing that you could ever experience as a programmer, watching ChatGPT write Python code in front of your eyes. And then you can see things like that. You ask it, oh, you want to do this certain thing, and it will write the code. And then you'll just say, well, actually, I prefer to do it this other way instead. And it will go back and rewrite that same code block over for you again. And then like when you generate the code and you paste it in your code editor and stuff like that, if you run into an error, you can take the error, paste it back into ChatGPT, and it will rewrite the code for you to fix the error and stuff. And from a development perspective, it's super phenomenal to see it in action and everything. And I've generated so much code since that Thanksgiving break, whatever, doing all sorts of things, like a lot of Retrotec related stuff or like business analysis stuff or plotting charts and working with a lot of the pressure gauge stuff I've been working on. I use it to analyze the data and everything from picking stocks to all sorts of things. Yeah, it's crazy. And I think that if you're not taking advantage of it as an individual or a company out there or whatever, then you're just going to fall behind at times because the people that are using it are just going to exponentially grow their minds.
With that in mind, what's your recommended on-ramp if somebody's interested in this? What should the first few things they do?
I'm sure a lot of people have to is ChatGPT. If you go to openai.com, you can try it for free. There's been a lot of iterations of the model, this large language model, but ChatGPT 4 is the latest version of it. And it got rid of a lot of those hallucinations and stuff when it was making up facts about things and everything. And it just comes up and it's prompting you, and then you have to know what to ask it for, which is the most important thing to figure out, really, is prompt engineering, they call it. Where
know how to ask the questions.
Yeah, you know how to ask the questions. Yeah, exactly. You can do anything from like, please draft an email to Bill Spohn and tell him that I'd love to be on the podcast. Can you schedule it for me? And then it will go through and write the whole email for you.
I did get an email today from a solar installer from South Carolina. At the bottom of the email, it said this was written with AI. They let me know, but it was like it was personalized, but it was not on target.
Well, that's the scary part. It's like, yeah.
And I had to read it and really see like, oh, this is written with AI. They just must have bought a mailing list or something to try to somebody in South Carolina to sell me solar in Pittsburgh. Just doesn't make sense.
Yeah, exactly. There's always that disconnect. And that's the scary thing too, is that I think another thing that people need to be a little bit cautionary about is like the spam that's about to hit us all in the next year or 2, 3, 5 years is just going to be crazy. And it's going to be sophisticated. It's like you said, like it's going to know like a little bit of research about you and send you emails that
Yeah, like as the owner of a small business and in the near Midwest, what do you think about this? Like, okay, they must know about me.
what is his beliefs and everything. Yeah. So I'd be on the lookout for that as well.
So speaking of, you said in the next 2 to 3 to 5 years, this change, when did you become aware of this? And I was going to ask, when did it become aware of you? But
yeah, it already knew about me. It already knew about TruTech and Retrotec and everybody already.
Have you been like tracking this for a while, or was it just something like popped up around Thanksgiving or Halloween or something?
Yeah, it just popped up around Thanksgiving where it was probably just a news article. And for whatever reason, ChatGPT just took off as far as people talking about it and stuff. And it was like right around, like I mentioned, that same time that I was starting to get into Python programming. And then by Christmas break, I was promoting it so much to like my poor relatives that all came here for Christmas break were just barraged with examples of how to use ChatGPT. But I actually like it influenced a lot. And then they come back to me later and they said, well, we actually took this back to the business and we're using it now for these different things, whatever. And thanks for the heads up, whatever. But and like I said, it's just going to be exponential takeoff from here on. I mean, there's talk about trying to slow things down with it and everything. But then it's just all the other countries that aren't going to slow down are just going to, like I mentioned before, if you're not using it for your business, just exponentially
blaze ahead.
Yeah. So I think we just have to embrace it and understand its limitations and what we need to be careful of or aware of.
I think I want to close with that thought. You did tell me a story. Maybe you don't want to share this in explicit detail, but you can actually pair two ChatGPT bots against each other.
On GitHub, you can go on there now and it's Auto GPT. You can download it. And what it is it takes two AI bots and you tell it some research or something that you want to do. And then they work together and try to figure out. And they go and search one thing that's limited now is like ChatGPT is trained up to a certain point in time. I think it's like
2021.
2021. Yeah, you're right. Exactly. But with this Auto GPT, then these bots will go out and do current searches on the internet for you. But they go off on some wild tangent stuff. Like you see, because you can watch them go through and you can see what they're doing and everything. And before you know it, they're off the mark. It's just entertaining to see whatever. But it's also a little bit scary to see what the potential is because you can really see these guys interacting with each other and progressing and thinking through things and stuff, which is the scary part.
Thinking.
Yeah, thinking, yeah.
Okay. I did say I was going to close on that note. So let's really do it this time.
I appreciate the podcast and everything and working with you guys, TruTech. Amazing team of people there as well and stuff. And always enjoyed talking with you guys and getting to hang out at these conferences and stuff. So it's a real joy.
And I wanted to give you the chance to talk about things that are in the background with product development, with your background, with other things that you find interesting. And I think that adds to the richness and the depth that you have a very interesting company there. And kudos on what you've developed and continue to develop.
Oh, thank you very much. And that's what my heart is. Like I said, I've been doing this since I was 12. Yeah, it's just in my nature.
Folks, retrotec.com, Ben Walker. It's been interesting having you here. And I'll have my bot call your bot for our next podcast.
Okay? Any future email from me, you'll have to question.
Yes.
Awesome. Well, thanks, Bill. I appreciate it.
All right. Take care. Thanks again for listening to this episode of the Building HVAC Science podcast. I hope you grab some information that'll shape your thinking, get you to try some new things out, or inform you. Other great trade-related resources and influencers out there include the HVACR School, HVAC Shop Talk, Stephen Reardon, HVAC Reefer Guy, Tool Pros, Service Business Mastery, Quality HVAC, HVAC Overtime, HVACR Videos, HomeDiagnosis.tv, AC Service Tech, and MeasureQuick. If you want to keep up with other things that I find interesting, follow TruTech on Facebook or follow me on LinkedIn. You can also find Building HVAC Science in the Facebook search bar. Thanks again for listening to the Building HVAC Science podcast. And if you're in the market for tools or test instruments, you can go to TruTechTools.com and use the code HVACBS for a nice discount. Thanks a lot. And we hope you're back again to listen to more episodes of the Building HVAC Science podcast. Take care.